metal printings, 3D plastic printings, various suitable applications. Though we are already granted more than 3 to 4 number of national and international patents together with Dr. Tariq, right? I really feel very unfortunate because we are taking the commitment, we are taking the responsibility to make the students learn and aware about the educational practices. As we are into private farms, right? Our responsibility is supposed to more than 100 times than in concern regular government or undertaking government or private farms. We supposed to produce much more effort individually and commitment towards student tech empowerments and particular science and engineering developments, right? And as per the AICT and UGC norms, whatever destructive technologies like your 3D printing, artificial intelligence, machine learning, I must, you know, request to Dr. Tariq sir, whatever business tools you are holding together for artificial intelligence, you kindly share with us and we can produce some quality index research paper with the same. Before starting of this webinar series, I requested Tariq sir to form a team so that we can publish some research papers. And very few, we had the conversations. Even if nowadays I'm not able to solve the WhatsApp properly due to lack of time. Sorry for that. You know, you're a very good friend of mine. Avilasha is there, right? So if you're talking about technology means you are the superb. You are the superb contributor for the society and you can achieve great for the commitments and for your individual knowledge acquirings. Make it very sure. I realize the things and practice the things into my individual life profiles. That's why I'm telling you. For educational, uplift based, if you're learning any kind of new tools, artificial intelligence, machine learning, 3D printing, something blah blah, data science, whatever, right? You are empowering yourself and through your knowledge, you are empowering others, your students, your faculties, your colleagues. Anyhow, you are contributing single percent knowledge to anybody. It's achievement. Knowledge always empower the things, right? The powerful tools of the world. Knowledge is the powerful tool of the world. You can defeat anybody. Make it very sure. And the kind of topic we are discussing today is 3D metal printing technologies, the modern manufacturing phase of metal products. Metal means what? Metal means something non-destructible. You can build anything. You can build any things, whatever you can see, whatever you can visualize, whatever things you can understand. With your imagination based, whatever engineering practices, innovations, incubation development, strategy learnings, you can build with 3D metal printing. And really, what it is exactly, the metal 3D printing, it is one kind of metal additive manufacturing technologies that is called AM. AM means additive manufacturing. Additive manufacturing means you are adding something layer by layer. The direct metal laser sinterings. Direct laser sintering means by the application of heat, you are melting the metals with computer vision systems, with computer numerography, with computer metallographic systems. Everything is computer related. And being a part of Synergy Institute of Engineering and Technology, let me tell you, in year of 2021, now we are holding more than 150 computer science engineering students at the first stream admissions. Due to the pandemic influence, computer science is the first and foremost department into education society. And I'm damn sure you guys also celebrating the same thing at your place. Maybe due to COVID situations, long distance health monitoring systems, impact of education system due to computer graphics, powerful tool sharing procedures, educational profilo, whatever, computer science and powerful tool engaged with computer science learned the society. 1.5 years or 2 years, still we are running with COVID. I'm telling you, more than 95% educational institute not yet opened in India, and still they are connected each other through computer science related softwares and tools. And in modern practice of era of 2021, computer science holding the right prospective positions into admissions, into educational practices, into industrial applications. Industrial application means into modern trade manufacturing process, number one. Into flexible manufacturing process, number two. Into CNC, computerized numerical processing methods, DNC, direct numerical computer process, a feasible designed parameters with software tools formed into practices of views literate with prospective ones converting into finished product. Computer science nowadays developed into that form, it can help the society almost in all the fields together. And we are very fortunate that being part of computer, we are accessing 3D printing, we are accessing your automatic robotic process automations, artificial intelligence, machine learning. Only terms are not sufficient. Require programming process, require technology access with executions, with knowledge process outcome as a living product. It's completely required. If you talk about 3D printing, I'm a guy of mechanical department, but still I'm trying to learn the things, computer visions, computer programmings we are using for the metal printing. Metal printing means you have to design the product using computer graphics tools like CATIA V6 and SolidWorks, render it and convert into STL format due allocations of simulations. Simulation means it's kind of powerful tool that validate your physical, mechanical, chemical, thermal, and electric properties of materials. It is the process by which parts are manufactured by the laser functioning together high performance of the metals layer by layer. And when we are talking about layer by layer means in 3D printing technology exactly, it means powder form of metals, powder form of metals using required segregate. Segregate means kind of granular structures. Required segregate were spreading over the sheets of 3D printing tables layer by layer, and we are focusing exact frequency of laser. Laser means stimulated amplification of lights with required temperature to melt the materials. For example, you are forming a metal sheet of 5 centimeter. 1 centimeter consider as a one layer. Next 1 centimeter consider as a second layer. Third centimeter consider as a third layers. So layer by layer, first of all, we'll spread all the granular size with required specifications of specification of specified. Specification plays very important role. Fine grade, medium grade, coarse grades. We are talking about the fine grade. Fine grade of metallic powders. Say your aluminum, titanium. Say aluminum corundums. Say aluminum phosphate limited chromium chromium metallic powders. Those are non-corrosive. And with respect to metallographic structures and alloying forming, plays a vital role into constitutional part of required properties hold together to form the metal printing. And nowadays our computer science softwares that much feasible can understand the allotropic, can understand the isotropic, can understand the metallographic constitutional development of different atomic structures, lattice formations, location of atoms into different lattices, different heat treatment to desired property of materials, to develop desired property of materials. Once again, allotropic formations for differentiating the alloying element of the metals. Up to that level you can find into CSIR. CSIR Government of India formed into 23 different sectors and spread over 23 different sectors across India. I'm a reach of CSIR Bhubaneswar. Using computer graphic systems, nowadays you can understand the metallographic structures, the constitutional features, the atomic arrangements, the allotropic formations, positioning of all the atoms with respect to different lattice points, kind of bondings, ionic bonding, covalent bondings, metallic bondings, electrostatic bondings. To understand the metals, you are not limited to only computer science different programmings. Make it very sure. Those students are participating, faculties are participating this, talk series. Make it very sure. Computer science nowadays not limited only C, Java, Oracle, .NET, Python. And if you are doing this, it's a mistaken. Mistaken is we are not want we never want to spread our knowledge. Nowadays you can find all the industrial automation, computer graphics, computer itself. We are the people, we are the people computer science, we are the people who automate the world with requirement based automation, say FMS, say CNC, say DNC. We are everywhere. We are the kind of guy having all the expertise with respect to requirement based, societal requirement based. Exactly we are doing with this process in 3D metal printing. For example, you are designing any part, regular or irregular. Make it very sure and underline please. First of all, we are taking the sketch, converting into CATIA V6 SolidWorks. Still few people are limited with Skylines and AutoCAD. AutoCAD is the practice of 1980s. If you talk about different companies like your Mahindra, Toriaris, John Deere, your Ashok Leyland, Maruti. Now all people are working with CATIA V6 and SolidWorks. Inferior quality required with mass production, you think of SolidWorks. Qualitative finished product required with less number of product outputs, you think of CATIA V6. Even if CATIA V5 already outdated in the year of 2004, 2005 onwards, most of industry, they are hiring mechanical and computer science student, graduates, diploma and postgraduates with sufficient knowledge of CATIA V6 and SolidWorks with hands-on learnings. Hands-on learning something, see, from the hands-on learning, I remember one thing that is called your skill development into minor project and major project submissions. And second one is your presentation skills through seminars. I still remember when as a student of Burla Engineering College, one of the primitive college here in India established in year 1925, I trembled. I, I trembled with fears when I standed in front of my teachers with one presentations for skill development seminars, grade of 003. Seriously. And that boosted me a lot. Right. So exactly in 3D metal printing, what exactly we are doing? We are designing something with our requirement based, number one. Number two, the design will convert to STLs. STL means stereolithography, right? After converting the stereolithography, as your computer not understand, 5 plus 6 equal to 11. We are converting binary format, right? So similarly, like your 3D printing, it's not able to understand direct plugins of your design practices, whatever you are doing in CATIA Basics and SolidWorks. We need to convert into STL, stereolithography. That's a readable language for the 3D printers, right? We need to convert it into STLs to the machine. Machine have a control panel and a screen where you can find execute, where you can find run the process, where you can find stop the process, where you can find the temperature of extruders, where you can find the processing speed, at which speed your plastic, metal, or biodegradable 3D printing filament will convert into layer by layer depositions. Likewise, you can find 5 to 6 number of options in your control panel. And nowadays, all the control panel of 3D printing machines are touch pads. You can touch it and you can execute it within fractions of seconds. It will take some time. Actually, in 3D metal printing, bioprinting, metal printings, we are melting the all supplied materials, may plastic, may metal, may biodegradable metal, but or non-biodegradable metals. You know, we're melting it. For melting, we required specific temperature. Two different type of temperatures are there. Number one is your executed temperature, that is your melting temperature. Second one, your elevated temperature. At elevated temperature, we are converting the properties of material with increasing or decreasing the percentage of carbon, because carbon plays vital role in all the metal non-metals. With percentage of carbon, you can design the product specification, you can design different property of materials, you can design kind of fabrication you exactly required best. And next to STL format, the program will execute with the control panel of the machine. Let me tell you the sequence once again. Number one, you have to design. And what are the design tools? CATIA V6 and SolidWorks. You can prepare CATIA V6. Then convert to STL. STL stands for stereolithography. Then from STLs, you send the document or data in form of document to the machine, 3D printing machine. Then 7 control panels are there. One control panel, 7 options, sorry, technical specification, 7 options are there. You have to choose your requirement based. And when we are talking about requirement based, let me tell you, one IT engineer is best one compared to one PhD holders. Make it very sure. One ITI holder next to diploma, next to BTech, next to master, next to PhD. One ITI holder is the best engineer of the world. Those are taking 1 year, 2 year internship or program learnings at the basic forms. They are touching the machine. Your computer even a machine. Please make it down, means note down please. Hands-on learning is the best practices into educational forums. Practicing the theorems, numericals, cases studies, only one citation required point of views. But whenever you are holding the machine, you are executing the task, you are able to find out the faults, remedies. You are able to understand touching, you are able to understand the fault of machines touching itself. I'm not that much aware about computers. I can understand the machine, kind of machines available with my under guidance. One ITI holder, one diploma holder, right? 100%, not 100, 100%. He can understand find the faults and difficulties of the machine, holding the machine at running condition for the first time. Make it very sure and online, please. They are the real practitioners. They are the real practitioners. So we are learning the theorems, they are different. You are learning the case studies, they are different. You are writing the scientific articles, they are different things. But the real practitioner who exactly working with the machines, one fitter grade, one CFD grades, one drafter, the real-time practical engineer for the industry standards based. And with all the confidence, I'm telling you, with all the confidence, they are the right people. So in metal printing, what exactly are doing? Using laser printing or right frequency of stimulated emission of radiations. We are melting the layer of materials formed into composition as a single and converting layer by layer depositions to get the desired product using computer aided manufacturing. That is 3D printing. With my knowledge based, this is the right definitions. Writing book, I'm not writing, research papers with respect to this context, but whatever my whatever things I learned from textbooks, experience, right? This is the right definition of 3D metal printing. You required you required any product. First of all, you design it. What is the powerful design tool? CATIA V6. CATIA V6 is the right form, right standard, and new technologies available in design fields. Convert into STL and with a specific material. That is called selection. That is called selection. Selection means with your knowledge, for example, Tariq sir, right? His short size is 40 or 42. I will ask, I need to buy a t-shirt for you, right? He will give his specification. My size is 42. I'll buy for him, right? It will fit for him. Similarly, when you are designing product and trying for the development, you have to select. That is called selection procedures. In every manufacturing process, computer graphic manufacturing process, you have to select. What to select? What is the current? What is the voltage? What is the frequency? What is the speed? These are the machining processes. Computer operated machining processes. You have to design it. That is called selection. If you are not designing properly means what? The t-shirt will not fit for the Dr. Tariq sir. Similarly, when I need to design in product, I have to select its material. I have to select its composition. I need to select computer graphic related tools and designs. I have to select the computer designed speed of the machine. I need to design the computer related voltage and frequency level of the machining process. I need to design the computer selected speed of spreading processes, computer designed speed of the tables, computer designed speed of the traverse process of 3D printing, 3D metal printing. I have to select. That is called selection procedure. For every product, make it very sure. For every product, we have to select it. You need to manufacture one furnace. Selection process is different. You need to manufacture keyboard of the computer using plastic printing. selection process is different. For that, we need experience. That's why experience produce value most with respect to educational qualification. Experience, right, produce much more value with respect to qualification concerns. Anyway, so how it is working exactly? The uses of power bed fusions, that is short term called PBF. Uses of power bed fusions. Power means what? The power required for the traverse movement. Traverse, two different type movements are there in 3D metal printing. One is traverse. Second one is reciprocating. Your table on which you are going to fabricate the product is traversing forward and backward direction. Reciprocating means with the opposite direction of traverse, making perpendicular, right formation of perpendicular to the traverse, you are continuing the movement of the speed of the positioning through the extruders. I think it's very complicated word to understand. Make a plus on your rough copy and put arrowheads in all four sides of the cross or plus something. One horizontal is there, one vertical is there. Try to understand the horizontals you formed with your rough copy is the to and fro motions of your bed, and traverse speed opposite to the to and fro of your bed sheet is the traveling of your extruders. Extruder means is the heating chamber in which you are heating the metal at right sufficient temperature, and plugins or spreadings or impingings or forecastings or depositing the melted materials at a right nozzle speed of 700 to 800 millimeter, because in all design practices we are talking about millimeter our standard design format, not centimeter. If anything given centimeter, convert into millimeter. You can easily understand from the engineering graphics. We all are engineering students, right? Chemical, fertilizers, or computer science. Engineering drawing is a common subject for all. In drawing standard is to convert of dimension into millimeter. That's why we're writing the demonstrator diagrams of all drawing sheets represented in millimeter. In this process, what exactly we are doing? Increases the temperature of the power in the areas where the design is being to build. Make it very sure. The laser converting the temperature of the powder, and therefore fusing the metals powder and creating solid layer by deposition rate of layer by layers. in plastic print, sorry, if you talk about conventional printing or conventional forming processes, what are the examples? Example number 1, your casting. Example number 2, your forming. Example number 3, your sintering. Example number 4, your annealing. Example number 5, your hot tempering. Example number 6, your squeezings. Example number 8, your quenchings. Example number 9, your forming processes. Example number 10, your different type of rollings. Example number 11, different type of extrusions. Nowadays, in industrial practices, everything is computerized. If you guys are thinking to limit your knowledge within only programmings, then bullshits. You are not doing anything. You are nonsense, bullshits. You are not learned the industrial standards. Nowadays, companies, industrial invokes, industrial practices, modern engineering practices, everyone is computerized to develop the productivity, to require or to meet the satisfied outputs of the company with stipulated timeframes, product to demand market, everything is computerized. I'll give a small example of 2 projects or innovation I'm working together. I already granted 100 patents. I forecasted 2 ideation. Number 1, your IoT based remote assisted neonatal caddy. Caddy is very beautiful word. CADDY. Caddy. Baby carriers. 21% of neonatal babies, 21, 21% of neonatal babies dying due to hypothermia during the transportation, lack of educational impact, due to lack of health education, health consultings. You rightly observe all India map, all the non-convenience places, all the remote locations, urban areas, semi-urban areas, right? 21% newborn baby premature deliver dying due to hypothermia. We already granted patents on same. We developed the prototype with my students and family members. We granted it. Earlier we formed one cost-effective thermal matrices. I think Dr. Tariq sir is very aware about it. And we spread it over whatever its success rate that different. But technically we granted with all kind of theoretical and physical development of the innovation. I developed the product even and nobody can discard it. Now the second form of the innovation is a carrier. Neonatal IoT based neonatal caddy. And how it is formed exactly? We developed one container. Nowadays I already converted and motivated my first year students, first year and second year students to develop this innovation into mechanical workshop. We are designing one caddy or carrier using one right angle formed metallic structures, number 1. Number 2, we are fitting one blower with it. Blower maintaining sustainable temperature within 36.5 to 37.5 degrees centigrade. one temperature regulator sensor, cost of 200 rupees, one digital display. Digital display will understand the amount of temperature, a kind of temperature available in CADI systems. One regulator, so manually you can control it. My required temperature is 36.5 to 37.5 degrees centigrade. Standard temperature. And we try to automate using one control panel. That's IoT operated or a hand-free operations to start, to stop, to optimize the process. And for that, you need a control system. Maybe your node MCU, maybe respiratory pipes, maybe your nano Arduino, maybe Arduino systems, or Wi-Fi, simple Wi-Fi you are using for the remote controlling systems for your AC and televisions. Start the thing, you can stop the thing, you can optimize the things, and it will be helpful. Not helpful, it will be a powerful tool. It's a powerful tool for the doctors, nurses, parents, ambulances, babies, premature babies. 99% of your Indian newborn babies are cesareans. No Indian mothers expecting normal delivery. Make it very sure and underline. And normal delivery means no need of care. Premature means you have to care. You need right feeding, right seedings, right cares, right breedings, right diapering. You have to take care of that. You have to keep in ICUs. You have to expense up to 10,000 to 15,000 per day. And for such kind of babies, you need intensive care all the time, starting from day 1 to day 21. This is the scientific and you can say spiritual engagement of newborn babies or homogeneity of new generations. You can search over internet. Your ancient politics is sufficient mature compared to the recent one. I'm telling you. You read Puran, you read Quran, you read Pothis, whatever you read, you can find the kind of superb knowledge, intellect that is called ancient knowledge. Nowadays, we are only following them. We are not Einsteins. Whatever ancient practices are there, we are following that ancient practice and using modern tool technologies, component together, we are only developing the things. Make it online, please. Ancient engineering practices is the powerful tool and technology provided over world spread for the human civilizations. Ancient engineering, ancient practices, ancient engineering tools and techniques. If you won't believe me, Tariq sir, you come to Delhi. You search over internet. Today, you please Google it. 10 beautiful temples in India. 10 beautiful temples in India. You can find, Tariq sir, Akshardham is the second beautiful temple. Buy a ticket of 150 rupees. There is a boat riding. Hopefully next month I will visit to Delhi. I must invite you. Buy a ticket of 150 rupees. Right? Visit to Akshardham. There is a underground boatings. There is underground boatings. You can find all the ancient practices, starting from computer science, mechanical engineering, electronics, starting from BDC to ADC, or you can say ADC to BDC. Everything is narrated with beautiful statues. I like to take my daughter even. That is so beautiful. You can understand all the engineering innovations, all engineering evolutions, all engineering evolutions, starting before 5,000, 6,000 year back to recent ages. And I hope if government of India will implement that every student up to class 12 or engineering graduation, they're supposed to visit Akshardham temple once. They can understand that how our engineering, may you are a computer science, sir, I'm a mechanical, but engineering is engineering, but students supposed to visit once. They have to search it and see it, that how engineering evolutions exactly happened, starting before 6,000 year to present era of 2021. So whatever, now we are talking about BAB, metallographic structures of 3D printing. So what exactly we are doing? We are designing the temperature. Temperature is called melting temperature of powder metals. Number one, speed at which your crystallographic structure is going to be deposit. When you are talking about 3D printing, you must clear about the crystallographic. Once again, I repeat, every property of material, say its strength, stamina, hardness, ductility, durability, grip, fatigue, different type of elongations properties, strain, stresses, feasible and physical metallographic structures, related properties, chemical thermal properties, everything depend on metallographic. How everything is arranged within a metal structures, and that completely depends on 4-5 parameters, that is called computer design temperature, computer design pressures, computer design traverse speeds, computer design table speeds, computer design extruders temperatures, parameter sets. Like this, we have to design everything using a computer. So in short, what we are doing in metal printing, we are selecting the materials. What are the materials? Anti-corrosive materials, low melting temperature materials, materials with proper physical affinity to join layer by layer, metals with right metallographic properties, metal having right affinity of moldability, because they are joined by layer, right? So these are the property you need to hold first. I'm the right partner. I'm running company Wigro Private Limited. Being a part of Synergy Institute of Engineering and Technology, now I'm also part of Wigro Private Limited. I'm appointed as chief scientist. Make yourself, make yourself that much, strong, that you can appoint yourself. Nobody can appoint you. Hold that kind of knowledge and commitment with you, and not commitment, make that much level of confidence within you, that I can build myself, nobody will build myself, right? Build yourself. If are And learning is, that's why from the beginning of this webinar series I defined you, learning is the most powerful tools. If you learn 3 to 4 hours day, nobody can defeat you. Learning, please make it underline and within apostrophe s. Learning is the biggest powerful tool. If you learn the things, world is bound to surrender. in front of you, because we are teachers, we are students. Our in our field we can do anything. We can learn, we can deliver, we can achieve, we can kiss the success. I still remember when when as a professor of your lovely professional university, Phagwada, Punjab. I started my career from there. Uh, I was a professor of manufacturing process, computer graphic manufacturing process, computer integrated manufacturing process. One guy written in examination answer sheet. That time we were very particular to check the answer sheet, to read the words, to read the wordings. One guy written like this: the technographic solutions. The technographic solution kissed KISSED, kissed, and within underline the particular word and kept into apostrophe s. Kissed the production, comma, still I remember the word production, desired market requirements, comma, desired market requirements, flexible orientation of modern era, modern, that 21st century. And he particularly underlined that word kissed, KISSED, kissed. And I furnished 9 out of 10 marks. 9 out of 10 marks. Because with the word he punched the emotion and intents of educational practices, of power of technology learning tools. Today we are learning from Abhilasha ma'am. Today we are learning from Tariq sir. I am also one teacher. Rather being a celebrating as a teacher, I always forecasting and find myself as a student within. Right? Anyway, so in metal printing, what exactly you are doing? You are designing a product, orders of metals, selecting machining parameters, designing it to steel formas and feeding to the machine, and 3D traverse speeds are sufficient to print the metals by layers, and you are getting the desired output of the products. Thank you. Any queries, questions? Please.